Hello friends, today we'll discuss about the working of insertion sort. So here I have written an example and I will let you know how insertion sort actually works. Okay, so insertion sort is something like sorting the card when you play card games and you sort the cards. So let me explain you the example. So the insertion sort has the concept of already sorted array. So this is my unsorted array 5, 2, 4, 6, 1, 3 and I want to sort it in increasing order. So I will start from the element number 2 and I will assume whatever is left from this element is already sorted. So I am assuming 5 is already sorted. So this is an array of size 1 and I am assuming this is already sorted. So now the idea of insertion sort is to put your current element into its exact position in already sorted array. Okay, now the size of already sorted array is 1 and I am going to add a new element into the already sorted array. So I need to create one place for it. So the size of the new sorted array will be already sorted array plus 1. Okay, so I need to create the place for it. It can be anywhere. So for this I will shift this element to its right position. So I shift it. So now my array is so after sorting this element, after putting this element into its exact location, the new size of the array will be 2. So I am shifting this element to its right. So when I will shift, when the element in the already sorted array is greater than this element, then I will shift that element into its right position, because I will put, so whatever is greater than from this element will be its right. So I will shift the 5 to its right position. So this will be 5 and 5. Okay, now the array size is 2. Now this is my very first element, so I cannot go back. So I will put my 2 here. So 5 will be its right. Okay, so now 2 is a key. So I am searching for its sorted place for this key. Now my sorted array size is 2 and I want to put 4 into this. So the new sorted array size will be 3. Okay, so since 5 is greater than 4, so I need to shift 5 to its right. So I shifted 5 and 5. Now my pointer reach here, but 2 is not greater than 4. So I will replace 5 by 4. So this is the exact place of 4. So the new sorted array size is 3. Now I have 6. Since 6 is, now I need to put the 6 into already sorted array. So if I compare, since this is this already sorted array, so whatever in its rightmost element should be greater than to current element, current key. So if the rightmost element is greater than the current key, then I need to shift it to its right, but this is not greater than 6, so it means this is already sorted array. Okay, now my pointer reach here. Now this is already sorted array, and the rightmost element is greater than 1, so it means I need to create a place into already sorted array for this element. Okay, so I will shift 6 to right, then I shift 5. Okay, when I shift 6, this will be 6 and 6 and 2, 4, 5. Now I need to shift 5 into its right position because 5 is greater than 1. Okay, this will be 5 and 5. Now I reached 4 is greater than 1, so I need to shift 4 to its right position. So now when 4 comes here, it will be 4 and 4, 5, 6 and 3. 2 is greater than my current key, so I need to shift 2 as well. So it will be 2 will come here. So 2 and 2, 4, 5, 6 and 3. Now I reach at the starting of the array, so I will just place 1 here. So this is my starting key. Now I reached at the end of the array. Now this is my already sorted array. I need to put 3 here. So I need to create a place for 3 in this already sorted array. So what I need to do is, first I will compare the rightmost element. So rightmost element is greater than the current key. So it means I need to find an exact place for current key into already sorted array. So I will just shift 6. So 6, this will be 6 and 6. Now I reach here. So since 5 is greater than 3, so I need to shift 5 as right. So this will be 5 and 5. Now 4 is greater than 3, so this will be 4 and 4. Now 2 is less than 3, so it means I need to put the 3 just right than the 2. So this will be sorted array. So the idea is to find the exact place for your element into an already sorted array. To start with, I had the sorted array of size 1, then I had the sorted array of size 2, then I had the sorted array of size 3, then I had the sorted array of size 4. So what the idea is to put your element into already sorted array, and you will shift your element into it right if the element is greater than the current key. Here I am not shifting because my key is greater than the rightmost element of sorted array. If rightmost element of sorted array is greater than the key, then I need to shift the rightmost element into its right position. Now this is the code for insertion sort. So here I am starting from element number 2 and I am assuming this element is a key. Okay, so in our example 5, 2, 4, 6, 1, 3. So I am starting from here. So this is the J. Okay, and this will be the key. So now I am starting from second element and I will be J minus 1. So this will be the I. Okay, so now here I am finding the exact place for this key. So if I is greater than or equal to 0, so I is greater than or equal to 0, I is 1, and AI, so I am assuming that my array is starting from element number 1. So I am assuming that it's starting from index number 1, and AI is greater than key. It means this one is greater than this one. So what I will do, I will shift it. So this code is shifting the element. So what it's doing, it's will placing AI at AI plus 1, and I am reducing the I. Now next time I will be 0 because I is equal to 1, so I will be 0. Mean this loop will not execute, and finally I will put AI plus 1 at key. So AI plus 1 means I 0 plus 1 equal to key. So here my I is equal to 1, and at this statement I will be 0. Okay, so if I look into, since I is not greater than or equal to 0, it means this loop will terminate. Okay, if it's terminate and will out of the loop, then AI plus 1 means A1 equal to key is 2. So I will place 2 here, and this is what this statement doing. This statement is doing is it's making this as 5. Okay, so this is the exact pseudocode for the insertion sort. Now I will let you know how to calculate the complexity for this insertion sort algorithm. Now let me calculate the complexity for this algorithm. So for calculating the complexity, we need to calculate the complexity for each statement. So now this is my very first statement. So this will execute the n times. Okay, this is starting from 2 to n. This will execute n time. So c1 dot n. So c1 is a constant term, means there could be a constant time. So I am assuming constant for all these statements. So c1 dot n. Now this is my second statement, and this statement will execute one less than the loop statement because there is a comparison statement. So c1 is for comparison. You can assume that whatever calculation is doing, c1 for that constant calculation. This will execute one less. So c2n minus 1. Similarly, this statement will execute one less. So c3n minus 1. Now I am here in this loop. So this loop will start from 2 to n. Okay, this loop will start from 2 to n, and this will execute 2 to n, and this is Tj is the complexity for this statement. Okay, so Tj is the complexity for this statement, and this statement will execute from 2 to n. Okay, now this statement will execute one less, so this will be Tj minus 1, and similarly this will execute 2 to n. This statement will also be Tj minus 1 because the loop body will execute at least one less than the loop statement. So loop statement execution was Tj, this will be Tj minus 1, and this will start 2 to n. Similarly, this statement is outer the loop, and this will execute n minus 1 because this is the inside of outer loop. Now to calculate the complexity of this statement, this insertion sort, we need to sum all these up. We need to sum up. Okay, and remember these Tj will decide the worst case, best case, and average case time complexity. Now let's calculate the best case complexity. So I have already told the complexity of this algorithm will be, if I add all the terms, so C1n, C2n minus 1 plus C3n minus 1, C4, C5, C6, and n minus 1. So now the best case complexity is, what will the best case? If algorithm is already sorted. So if algorithm is already sorted, so it means this statement will execute only once. The internal loop statement will execute only once. So what does it mean? Tj is equal to 1. Okay, so if I put Tj equal to 1, so this will be 1, and this 1 minus 1 will be 0, so this term will be eliminated. This 1 minus 1 will be 0, so this term will be eliminated. Now remaining terms are C1, C2, C3 plus n minus 1 and this one. So now what will this? Let's calculate this. So this will be C4 J2 equal to n 1. So if I sum up 1 plus 2 to n, so this will be n minus 1. This will be C4n minus 1. So remaining terms will be C1n, C2n minus 1, C3n minus 1 plus C4n minus 1 plus n minus 1. So if you look into, so this is similar to all the terms are in the form of n. So it will look like an plus b. So how does an plus b comes? So this so idea behind is, if I segregate these terms, so this will be look like this as n C1 plus C2 plus C3 plus C4 and 5n and 5. This will look like, this is my A plus B. So this is in the form of an plus b, and in the power of single power of n. So the best case complexity for insertion sort is order of n. Now let's calculate the worst case time complexity for this algorithm. So in the case of worst case time complexity, this while loop will execute n times. Okay, so if this executes n times, then Tj will be n. So this Tj will be n. So if I calculate this Tj by summation series, so this will be C4 j is equal to 2 to n, this will be n plus 1 by 2. So this will be order of n square. So if any term in this complete statement is in the form of order of n square, so the total complexity will be order of n square. Similarly, for the average time complexity, so the average time complexity means all the terms, half the terms from your key is less than the key and half the terms are greater than key. So it means this loop will execute at most n by 2 times. So if I calculate C4 j is equal to 2 n by 2, so this constant term will come out. So there will be C4 by 2 and j is equal to 2 to n by 2. So this will again be in the form of n plus 1 by 2. So the average case time complexity for insertion sort is also order of n square. So that's all from insert sort. Thanks for watching. Please subscribe my channel.